Hello there, and welcome back to the Sleep Science, or you're floating again, somewhere between the edge of sleep and the edge of the universe. The stars above you seem alive tonight, whispering, pulsing, shifting ever so slightly, as if they're conspiring to tell you a secret. You tilt your head, half expecting to see what they're hiding, but all you find is a strange stillness in the dark. Out here, everything glows where it shouldn't, bends when it shouldn't, and moves as if pulled by invisible hands. It's the cosmic version of a ghost story, except this one is true, or at least as true as physicists can currently guess. And you, brave sleeper, are about to wander into it. You probably won't survive this in one piece. Intellectually, I mean. Once you glimpse what's truly missing from the universe, it's hard to go back to thinking the night sky is simple. So before you get comfortable, take a moment to like the video and subscribe. But only if you genuinely enjoy what I do here. And tell me in the comments, where are you watching from, and what time is it in your corner of the cosmos? Now, dim the lights, maybe turn on a fan for that soft background hum, and let's ease into tonight's journey together. You begin adrift in interstellar black, no spaceship, no noise, just your breath echoing through the vacuum like a gentle tide. Around you stretch the galaxies, each one a colossal whirlpool of light spinning faster than reason allows. You watch them turn their spiral arms, flinging glittering stars into the abyss, yet somehow nothing flies apart. The numbers don't add up. By all classical laws, Newton's tidy equations, Einstein's elegant curves, these galaxies should have long since torn themselves to luminous shreds, but they haven't. Something unseen is holding them together. Something vast, silent, and strong enough to outweigh all visible matter combined. You glide closer to a spiral galaxy that reminds you vaguely of the Milky Way, and you can almost feel its rotation tugging on you, like the faint pull of a tide. Astronomers once noticed this same pull in the 1930s when a Swiss astrophysicist named Fritz Zwicky studied the Coma cluster. He calculated the speeds of galaxies swirling within it and found that, by visible light alone, they were moving far too fast to be bound together. It was as if an invisible glue kept them from flying off into intergalactic oblivion. Zwicky, being both brilliant and charmingly irritable, called the missing substance Dunkel materia dark matter. For decades, most scientists shrugged. Maybe he'd miscalculated. Maybe telescopes lied. After all, who wants to admit that 85% of the universe is missing from the inventory? But time and better instruments proved him right. By the 1970s, astronomer Vera Rubin mapped how stars orbit around galaxies and confirmed the same haunting pattern. The outer stars weren't slowing down as they should. Something unseen was adding mass that neither shone, nor reflected, nor absorbed light in any detectable way. Rubin's calm persistence, paired with her love of midnight sky patrols, cemented dark matter as a legitimate cosmic mystery. You hover now, watching the same physics unfold. A star near the edge of the galaxy streaks by, its orbit steady, almost defiant. You imagine if it could talk, it might whisper, "I'm held by something you can't see." That's the universe's first great joke tonight, that most of what's real doesn't care whether you can look at it. Historians still argue whether Zwicky's reputation, grumpy genius or visionary outcast, helped or hindered dark matter's early acceptance. Some say his abrasive personality turned people off the idea for decades. Others insist the theory was simply too radical for its time. Either way, it was Rubin's grace and persistence that gave the concept new life. You drift onward, deeper into the dark. Around you, faint light stretches like silk, bending and twisting in patterns that make no intuitive sense. Every photon, every quiver of starlight feels like a message from the hidden world behind the visible one. You sense it, this unseen architecture, this cosmic scaffolding, but can't touch it. It's like trying to feel the wind inside a dream. Some fringe thinkers once proposed that dark matter might not be matter at all. Maybe it's a trick of space-time or a byproduct of dimensions curling up like shy kittens. One even suggested the entire universe might be a holographic projection, and dark matter the static between pixels. It's a poetic notion, if not a particularly helpful one when you're trying to balance galactic equations, but it does make you wonder, what if the universe is simply bigger than our instruments can grasp? So much so that dark is just another word for beyond comprehension. A dust-coloured comet drifts past you. its frozen gases glowing faintly in reflected starlight. You watch it curve through invisible influence, its trajectory subtly altered by something you can't name. The realization comes quietly. You're not floating through empty space at all. You're moving through a vast ocean of unseen gravity, a sea of particles, or maybe not particles, shaping every motion, every orbit, every quiet breath of cosmic time. The scientist in you wants a number, a label, a grasp, but the dreamer in you is content to let the dark remain nameless. The beauty of it lies in its silence. Even physicists, those proud custodians of certainty, admit they might never see it directly. They just watch the stars, the galaxies, the cosmic structures, and read the shadows they cast. A tiny satellite blinks by, its signal lost to cosmic background hiss. Down on Earth, somewhere in the small hours, a graduate student stares at data that look like nothing. Yet inside that nothing might be everything. You smile to yourself, realizing the absurd scale of it all. We live inside a mystery so large, our entire species might never truly measure it. And yet the search continues, quiet, stubborn, almost devotional. The stars above hum faintly, as if approving your humility. You close your eyes, floating weightless, between what's known and what's unknowable. Knowable. The dark hums softly beneath your thoughts, not threatening but tender, like the pulse of the cosmos itself, whispering a lullaby you can't quite hear. You drift through that cosmic silence, the kind that hums behind your ribs rather than your ears. The stars stretch like a luminous map of forgotten thoughts, and somewhere in their glow lies the city of the universe's missing weight, the hidden mass that keeps everything from falling apart. You watch galaxies wheel and tumble, and as you move among them, it feels like witnessing an enormous slow-motion dance that's somehow choreographed by something you can't see. The visible matter, stars, dust, gas, isn't nearly enough to explain the steps. The dance should fall apart. The outer edges of those galaxies should fly away into cold emptiness, but they don't. Something invisible keeps the rhythm steady, a silent partner guiding the movement. You can picture the astronomers of the mid-20th century huddled in dark observatories, watching spectral lines drift across glass plates. Each line told a story about motion, about mass, about forces unseen. And when Vera Rubin began to trace those lines for distant galaxies, she found something strange. The stars near the outer edges were spinning as fast as those near the center. That wasn't supposed to happen. It was as though an invisible weight surrounded every galaxy, providing gravity that held the spinning stars in place. Rubin's work confirmed what Zwicky had only guessed decades earlier. The universe's luminous matter was just a sliver of the full picture. Historians still argue whether Rubin's discovery was as revolutionary as the invention of the telescope itself. Some claim she quietly redefined cosmology. Others insist her results simply confirmed what physicists already suspected. Either way, her patience rewrote the boundaries of cosmic understanding. She once said she felt privileged to look at the sky when no one else was looking. There's something gently heroic about that, a reminder that the greatest discoveries often happen in solitude, under the cold patience of starlight. You imagine her late at night, surrounded by humming machines and the smell of coffee gone cold. On her screen, the galaxy's rotation curve refuses to decline. It stays flat, stubbornly so, like a cosmic dare. She doesn't dramatize it. She just notes it, plots it, repeats the observation until even the skeptics have to squint and nod. There's something oddly comforting in that persistence. The universe reveals its secrets not to those who shout, but to those who quietly listen. You float closer to one of those galaxies now, its disk glowing blue with new stars. Its halo a whisper of invisible substance that stretches far beyond the visible spiral. You can't see the dark matter, but you can feel its presence in how the starlight bends. If you were to paint it, you'd use nothing but gravity and patience. Astronomers sometimes describe this unseen mass as a kind of scaffolding, a framework of gravity around which normal matter gathers, like frost forming along invisible threads. It's poetic in a geeky kind of way. Fringe theorists in the 80s once suggested that maybe the dark wasn't matter at all but faint celestial junk. Brown dwarfs, failed stars, rogue planets. They called them machos, massive compact halo objects. It's one of those rare scientific acronyms that sounds like it's flexing at you. For a while it made sense. Perhaps space was full of cold, dim objects too small or too faint to see directly. But over time, careful surveys, like the Macho and Eros projects, looked for the subtle brightening that would occur when such an object passed in front of a distant star. They found a few candidates, yes, but not nearly enough. The missing mass was still missing. The universe, it seemed, preferred to stay mysterious. As you move through the halo of this imagined galaxy, you sense that dark matter isn't distributed evenly. It clumps, ripples, forms halos upon halos. Computer models suggest that every visible galaxy floats inside one of these vast cocoons, invisible yet massive beyond comprehension. If you could somehow touch it, your hand would pass through without resistance, though gravity itself would bow around your gesture. There's a quiet thrill in that thought. You are surrounded by something that refuses to interact with light, with matter, with you. It's there but untouchable, like an idea that can't be forgotten once imagined. And maybe that's why the term dark feels so appropriate. Not because it's sinister, but because it's private. It's what the cosmos keeps to itself. Astronomers today estimate that about 27% of the universe's total energy density is dark matter compared to less than 5% of ordinary matter, the kind that makes up everything from stars to snails to your tired eyes reading these words. The rest? That's dark energy, an even stranger beast that we'll meet later. For now, you hover in the comfort of gravity's embrace, aware that nearly everything around you is invisible, yet undeniably real. You look back toward the Milky Way, faintly glowing behind a haze of interstellar dust. You realize that your own galaxy spins too fast for the sum of its visible stars. Without dark matter, Earth's solar neighborhood would be flung into the void like glitter in a storm. The thought makes you shiver slightly, not with fear, but with awe. We owe our stability, our very existence, to something we cannot detect except through its pull. The universe is basically holding us in its invisible hand, and we have no idea what that hand is made of. Historians still debate whether that realization changed humanity's philosophical perspective as much as it changed science. Some argue it humbled us, a second Copernican blow reminding us we're not even made of the main ingredient of the cosmos. Others think it inspired us to search harder, to invent detectors buried in mountains and sensors cooled to near absolute zero. Either way, dark matter became less of a riddle and more of a companion, something constant, unseen yet always near. A distant quasar flickers like a candle in the void. The light takes billions of years to reach you, bending subtly as it passes through invisible gravitational wells. You watch that distortion and think, this is what belief looks like in physics, trusting the shape of what you can't see because of how it moves what you can. There's poetry in the math and perhaps a bit of faith too. You exhale into the infinite dark. Somewhere beneath you, Earth spins quietly, wrapped in its own dark halo, every sunrise secretly cradled by matter that never shines. The universe breathes with you, its unseen heart steady and patient. The hidden weight of existence hums in the distance, and you realize it's not just out there, it's around you, through you, in you. You continue drifting along the outer rim of that glittering spiral, watching stars whirl like tiny sparks in a black ocean. The rotation is hypnotic, smooth, precise, yet utterly illogical by Newton's standards. If you toss a rock in orbit, the farther it is from the center, the slower it should move. But here, the stars ignore that rule, circling the galactic core with the same dizzying speed as those near the middle. It's a celestial traffic jam that refuses to make sense. You think of it as a galactic ballet gone wrong, every dancer twirling at the same frantic tempo, defying physics with elegant disobedience. Something unseen is calling the tune. Astronomers once thought they could fix the choreography by tweaking the equations. Maybe Newton's old gravity formula, written under apple trees and candlelight, wasn't enough for cosmic scales. Einstein's general relativity added some grace, curved space-time, bending light, but even that wasn't sufficient. The galaxies kept spinning too fast, as if bound by an invisible conductor waving through the void. That's when dark matter stepped onto the stage, a ghostly understudy, never seen, yet essential for keeping the universe's performance from falling apart. Historians still argue whether dark matter's rise to fame was more about evidence or desperation. Some say it was the only explanation that fit. Others whisper that physics simply needed a placeholder until something better came along. Either way, the invisible actor stayed. And audiences, by which I mean astrophysicists, gave it standing ovations. You glide toward the galactic centre, that blinding whirlpool where stars swarm like moths around a flame. Beneath their glow lurks a supermassive black hole, but even its gravity can't explain the outer star's speed. You watch the invisible influence of dark matter stretch far beyond the core, forming a halo that wraps the galaxy like a transparent cocoon. Without it, the whole structure would unravel, its stars cast adrift like glitter, spilled across infinity. You realize with a kind of sleepy awe that the universe's beauty depends on something we can't even see. A comet streaks by, trailing dust and ice, like punctuation in this cosmic sentence. You think about how many times humanity has rewritten the rules of the universe. First, Earth wasn't the center. Then, the sun wasn't either. Then galaxies, once thought to be rare, turned out to be countless. And now, even the stuff we can see is the minority. It's humbling, a little funny, and profoundly comforting in a strange way. The cosmos doesn't revolve around us, but it doesn't exclude us either. We're part of its absurd equation, woven into both the visible and the unseen. There's a quiet rhythm to it all, like a heartbeat pulsing beneath the stars. You feel that pulse through the soles of your imagination as you drift farther from the galaxy's core. Around you, faint light bends, an effect called gravitational lensing. You watch distant galaxies distort into arcs and smudges. They're like twisted by massive halos of dark matter. It's as if space itself were a soft lens, revealing the fingerprints of the invisible through gentle warps in brightness. That's how scientists map what they can't see, by tracing the way light misbehaves. Fringe researchers have suggested alternative ideas. Maybe gravity doesn't behave the same on cosmic scales. Maybe it weakens slower than we think, or maybe space has hidden dimensions where the extra pull hides. Modified Newtonian dynamics, MOND as it's called, tries to explain the same observations without invoking invisible matter. It's a neat idea, one that gives gravity new tricks, but most astronomers find it struggles to explain everything at once. The motions of galaxies, the lensing of light, the formation of clusters. The dark matter hypothesis, while mysterious, ties it all together with eerie consistency. Still, historians note that scientists are rarely satisfied with mystery. They crave certainty, and dark matter refuses to give it. You glide past another spiral galaxy, its arms stretched like smoke rings in slow motion. You realize every one of these cosmic whirlpools dances to the same unseen rhythm. If you could turn dark matter into sound, the universe might hum like a massive invisible cello, its deep notes vibrating through space-time. The thought makes you grin sleepily. It's hard not to find comfort in the idea that the universe has a kind of music, even if we can't hear it directly. You think of Einstein again, his equations carved into the history of thought. He once admitted that his general relativity was incomplete, that something was missing in the way gravity played out across the cosmos. He couldn't have known how prophetic that humility would be. Today's cosmologists build on his work, layering invisible scaffolds on top of invisible forces, trying to explain how galaxies stay together. They run simulations filled with trillions of digital particles, phantom matter that tugs and clusters just like the real thing. When those models recreate the universe we observe, it feels like a kind of cosmic confirmation. Maybe the ghosts are real after all. Still, it's tempting to think dark matter could be an illusion, a trick of perspective like a mirage on a desert road. But every new measurement, every distant galaxy observed seems to whisper the same truth. Something unseen is out there, sculpting the universe. You reach out, hand trailing through imaginary halos, and feel the chill of understanding, knowledge without visibility, faith without proof. Historians still debate whether the human brain was ever meant to comprehend scales like this. Some say our pattern-seeking minds are ill-equipped for the cosmic. We're built for campfires, not quasars. Yet here you are, afloat in mental space, wrapping your thoughts around phenomena billions of light-years wide. The stars spin on, unbothered by your awe. They've been performing this impossible dance for eons, oblivious to human curiosity, yet somehow perfectly synchronized by a silent, unseen rhythm. The dark matter doesn't glow, doesn't shimmer, doesn't even whisper, but its influence is everywhere, in the orbits of stars, in the shapes of galaxies, in the curvature of space itself. You let that thought settle, a soft weight pressing against the edges of your awareness. The universe, it seems, is a shadow play. Light is the illusion, the dark does the work. And as you drift on through this stellar waltz, eyelids heavy, you feel oddly grateful for the invisible, for the forces that hold things together even when you can't see them. Maybe you think that's how life works too. You're gliding now through a cosmic landscape that seems woven from smoke and gravity. Galaxies rise and fade like ripples in a midnight pond. And as you drift closer, you notice something extraordinary. Each galaxy isn't just floating in space, it's nested inside a vast, invisible sphere of dark matter. You can't see it, but you can feel its presence in the way the starlight bends and the gas clouds cling. The visible parts, the bright disks, the star clusters, the glowing nebulae, are just frosting on a massive transparent skeleton. Dark matter, the universe's hidden architect, is the invisible sculptor of galaxies. You imagine this unseen framework forming billions of years ago, before the first stars even flickered to life. In those early days, the universe was a uniform fog of hydrogen, helium, and possibilities. Tiny ripples in density, cosmic wrinkles left over from the Big Bang, gave dark matter places to gather. It didn't shine or interact with light, but its gravity pulled on everything around it. Slowly, it formed halos. Gravitational wells deep enough to trap gas. That gas cooled, collapsed, and ignited into stars. Without those halos, there would be no galaxies, no suns, no you floating here now trying to fall asleep while contemplating the universe's construction manual. Historians still argue whether we should call dark matter the true backbone of the cosmos, or merely its scaffolding. Either way, it shaped the architecture of everything visible. You drift over a vast cluster, thousands of galaxies embedded in overlapping halos, each invisible bubble brushing against its neighbours like soap films in slow motion. If you could see the dark matter directly, it would look like a gossamer web, threads connecting nodes where galaxies form, a grand cosmic lattice stretching across billions of light years. Scientists call it the cosmic web, and you can almost imagine spiders the size of universes spinning it, humming softly in the dark. A faint glow flickers near you, the ghost of starlight from a galaxy 10 billion years away. Its light has travelled through dark matter fields that subtly bent its path. The image is stretched, warped into a graceful arc. You realise you're witnessing gravitational lensing again, the same phenomenon that lets astronomers map invisible matter by observing how it distorts light. It's like tracing fingerprints left by a transparent hand. You float onward, tracing those delicate filaments. Every so often you pass through an empty void, vast regions nearly devoid of both visible and dark matter. The silence here feels deeper somehow, a kind of cosmic negative space. And yet even these voids are shaped by the dark's gravitational outlines. You realise the universe isn't just filled with matter, it's sculpted by absence, balanced by invisible tension. If dark matter vanished overnight, galaxies would unravel, clusters would drift apart, and the cosmic web would disintegrate like dust in wind. Everything you know, the Milky Way, the sun, your sleepy thoughts, depends on something utterly untouchable. The irony makes you smile. Humanity built entire civilizations by manipulating what it could see: wood, metal, stone, and now we find that the majority of reality is invisible. You picture some ancient philosopher staring up at the stars and insisting that the heavens were made of pure light. He'd be shocked to learn that light is only a thin garnish on the universe's dark feast. You pass near a forming galaxy, a chaotic whirl of hot gas and newborn stars. Supernovae pop like champagne corks, scattering heavier elements into space. Beneath the fireworks, a vast halo of dark matter steadies the chaos, providing the gravity that keeps everything in place. You realise it's like an invisible parent, never in the photos, but always holding the family together. Without it, these cosmic infants would spin apart before they had time to grow. There's something oddly comforting in that thought. Even the grandest explosions need a quiet hand to anchor them. Scientists believe that dark matter halos act like gravitational incubators, collecting gas where galaxies can form. The more massive the halo, the larger the galaxy. The Milky Way's own halo stretches hundreds of thousands of light years beyond its visible disk, containing perhaps 1 trillion solar masses worth of invisible matter. And inside it, here you are, a whisper among the starlight. Historians still debate how exactly these halos assembled. Some say they grew hierarchically, small clumps merging over time into larger structures, the cosmic equivalent of cities swallowing villages. Others think they formed more smoothly, collapsing directly from early density fluctuations. The truth likely lies somewhere between, like most things in science and in life. You think of it as a cosmic jigsaw puzzle still missing a few pieces, though the picture is already breathtaking. Down in laboratories on Earth, scientists simulate this galactic evolution using supercomputers that model billions of particles, each one a stand-in for dark matter. You picture the glowing screens, the hum of processors, the quiet thrill when the simulations recreate real galaxies. When the digital halos line up with telescope data, it's like the universe winking back in confirmation. For a fleeting moment, you realize human beings understand the cosmos. Not entirely, but enough to marvel properly. As you drift through another cluster, you catch sight of something strange. Faint streams of stars stretching between galaxies, like bridges of light. These tidal tails are relics of gravitational encounters, evidence of galaxies colliding and merging. When they do, their dark matter halos also intertwine, forming even larger structures. It's cosmic romance on an unthinkable scale. You chuckle softly. Apparently even galaxies can't resist getting a little entangled. Somewhere behind you, a faint echo ripples through the void, a gravitational wave passing silently through your awareness. It's a reminder that even the invisible has motion, that space-time itself can tremble. You close your eyes for a moment and imagine the universe breathing, expanding, cooling, coalescing, its invisible scaffolding holding everything steady while the luminous parts play at being beautiful. You think back to that first moment when you realize dark matter isn't just a mysterious substance, it's the foundation of cosmic architecture. The universe isn't built from light, but balanced upon shadow. It's a funny reversal of everything you were taught as a child, that light reveals truth and darkness conceals it. Here, it's the darkness that gives structure, and light merely decorates the surface. Somewhere, billions of light years away, another galaxy spins, its stars bound by unseen gravity. The pattern repeats endlessly, a fractal of order sustained by what cannot be seen. You smile because suddenly it doesn't feel frightening, it feels harmonious. The invisible sculptor isn't a menace, it's an artist, and as you drift on and the stars seem to nod in sleepy agreement. You float now toward a region of space where violence once painted its masterpiece, a colossal collision frozen in time. Before you stretches the bullet cluster, two galaxy clusters that slammed into each other millions of years ago with the kind of cosmic force that humbles human imagination. Each cluster contains thousands of galaxies, vast clouds of plasma, and of course the invisible weight of dark matter. The aftermath still glows faintly in X-rays, like embers cooling after a universal bonfire. You can almost hear the silence that followed the impact, a silence so profound it swallows thought. From your drifting vantage point, the scene seems calm, even graceful. But behind the serenity lies motion beyond comprehension. The visible matter, the hot gas that makes up most of what telescopes can detect, lags behind, so by collision and friction. The dark matter, however, sails right through, utterly unfazed. It neither collides nor slows down because it doesn't interact with ordinary matter except through gravity. It keeps moving as if nothing happened, a ghost army marching silently through the chaos. The separation between the visible gas and the invisible halos is the universe's own confession. Dark matter exists. You imagine the scientists who first mapped this cosmic aftermath in 2006, combining optical and X-ray observations. When they overlaid the data, they saw something startling. The bulk of the mass wasn't where the luminous gas was. Instead, the gravitational lensing revealed the mass had passed through the collision, detached from the glowing plasma. It was the clearest evidence yet that dark matter wasn't just a mathematical trick or a gravitational illusion. It was something real, something with substance, though not in any ordinary sense. Historians still argue whether the bullet cluster was the definitive smoking gun for dark matter. Some call it the most convincing evidence in astrophysics. Others insist that modified gravity could, in theory, still explain parts of the observation. But for most, this cosmic car crash sealed the deal. You look at it and see the universe's curtain drawn back, revealing a skeleton made of invisible mass. You drift closer, through fields of hot gas shimmering in false colour hues, magenta, violet and gold in telescope composites. It looks serene, but temperatures here soar to tens of millions of degrees. The plasma glows in X-rays, yet the dark matter remains indifferent. It doesn't scatter light, doesn't heat, doesn't glow. It just is. You realise with an amused sigh that dark matter might be the introvert of the cosmos, present at every party, speaking to no one but somehow holding the whole event together. Below you, the galaxies themselves glide on, mostly unharmed. They were like fireflies passing through clouds of smoke, each one too small compared to the vast halo of dark matter surrounding them to suffer much. You watch them pass each other slowly, their trails blending into the background. The collision you're witnessing isn't like explosions in movies, it's more like two ghosts walking through one another, their outlines briefly distorted, then restored. The idea that something invisible can shape the fate of entire clusters is both unsettling and deeply poetic. You think of Earth, so fragile and small, wrapped in its own dark halo. Every rotation, every orbit, every stable sunrise owes itself partly to this same unseen presence. The universe hides its support beams well. Some fringe thinkers argue that the bullet cluster might not be as decisive as it looks. A few insist that maybe the data are incomplete, that other unseen forces or modified gravity equations could mimic the same pattern. But you smile at the thought. Science, after all, thrives on argument. The truth is never afraid of debate. It just waits patiently in the background, like dark matter itself. As you glide farther into the cluster, you notice arcs of light, background galaxies stretched and magnified by gravitational lensing. These distortions, subtle yet measurable, act like fingerprints of the invisible. Astronomers use them to map the distribution of dark matter across the cluster, creating ethereal blue overlays that reveal where the true mass lies. You realise this is the modern art of cosmology, painting with gravity instead of pigment. You pause over the region where the two dark matter halos overlap, a place where invisible gravity wells intersect. If you could hear mass as sound, this might be the deepest note in the cosmic symphony, a sub-bass rumble stretching across millions of light years. It's strange, but you feel it in your chest, even though you know it's imaginary. Science and imagination blend so easily out here. Historians still discuss what discoveries like this mean for philosophy. The bullet cluster proves that the universe contains entities that don't behave like anything on Earth. They don't emit light, absorb radiation, or obey familiar chemistry, and yet they dominate the cosmos. It's a quiet existential reminder. The laws of nature are vaster than the realm of human experience. For all our telescopes and theories, we're still guests in a house whose architecture we barely comprehend. You drift backward now, taking in the entire cluster once more. From this distance, the scene looks peaceful again. Two clouds merging in slow, cosmic embrace. The violence that created it is long past, yet its evidence endures in the gravitational scars imprinted on space-time. You think of it as the universe's way of journaling. Each collision a new line in an ancient diary written without ink or sound. A stray thought crosses your mind. Perhaps dark matter is more than matter. Perhaps it's the memory of the universe itself, the residual structure that remains after light fades. It's not science, not really, but the idea feels soothing, like a lullaby hummed by creation itself. You smile at the absurdity and beauty of it all. The bullet cluster fades behind you, its faint glow softening into the starry horizon. The invisible halos remain, their quiet gravity reaching farther than imagination can stretch. The galaxies continue their endless orbiting, oblivious to observation, perfect in their mystery. And as you drift away, you can't help but whisper a thank you to the unseen, to the silent architect, to the dark matter that holds the universe steady. Without it, even dreams like this would scatter into nothing. You drift now through a grand tapestry of existence, the cosmic web, where the entire universe reveals its hidden architecture. From this impossible vantage point, you see it all. Billions of galaxies strung together by invisible filaments, weaving a vast intergalactic net that stretches across the observable cosmos. The light of the galaxies glimmers faintly, like dew caught on an enormous spiderweb spun out of gravity and time. Between the threads lie immense dark voids, cosmic deserts where almost nothing resides. It's haunting, beautiful, and eerily mathematical. The structure isn't random, it's as if the universe followed some ancient blueprint, one written. by the unseen hand of dark matter. You drift along one of these filaments, watching galaxies glide in clusters, drawn by the same invisible force that keeps their internal stars bound. Here, dark matter is not merely a halo around individual galaxies, it's the connective tissue of the cosmos. Each strand holds countless halos, linked like pearls along invisible strings. You can't see it, but the effect is everywhere. Galaxies cling to the filaments as water droplets cling to silk. If you close your eyes, you can almost feel the gentle tension of gravitational threads stretching endlessly in every direction. Historians still argue whether the term cosmic web is too poetic for a scientific concept. Some purists insist it sounds mystical, while others admit that no technical phrase could better capture its elegance. After all, when astronomers mapped the large-scale structure of the universe using data from surveys like the Sloan Digital Sky Survey, they found that reality itself looked poetic, an enormous three-dimensional lacework shaped by the gravity of dark matter. The faint glow you see from faraway galaxies is merely the frosting. The true substance is hidden. When cosmologists run simulations, they begin not with stars or gas, but with dark matter alone. They feed in the laws of physics, a few starting ripples from the Big Bang, and then watch as gravity sculpts the result. The patterns that emerge in those digital universes match what telescopes observe in the real one: long filaments, vast nodes, and yawning, empty spaces. The dark matter forms the stage. Light is merely the decoration that reveals it. As you glide farther into this web, you pass through one of its junctions, a knot of intersecting filaments where clusters of galaxies congregate. It feels like a metropolis of light, each galaxy orbiting within a larger gravitational city. Streams of hot gas flow along the filaments into these hubs, feeding new stars. It's cosmic urban planning, executed over billions of years, with dark matter as the invisible engineer. You can almost imagine it humming softly, content with its eternal construction project. Fringe theorists have occasionally suggested that the cosmic web might itself be conscious, that perhaps complexity on such scales could host a kind of intelligence. You smirk at the idea, it's romantic nonsense surely, but as you float through this shimmering, interconnected structure, you can't quite dismiss it. The pattern feels alive. It pulses with rhythm, balance, and strange harmony. Maybe not conscious in any human sense, but purposeful. Closer now, you see a galaxy cluster strung along one filament like a bead on thread. The galaxies here are not isolated. They tug on each other, dance around shared centers of mass, and sometimes merge in luminous flares of creation. Through it all, the dark matter provides the scaffolding, holding the geometry steady even as light flickers and fades. Without that invisible framework, the universe would have remained a formless fog. You think about that. A cosmos with no galaxies, no stars, no places for life to form. The dark, it turns out, is the reason for every sunrise. Historians still debate how early thinkers might have reacted to this revelation. In ancient times, philosophers imagined crystal spheres or divine geometries to explain the order of the heavens. The truth turns out to be both simpler and more mysterious. Gravity alone, sculpting invisibility into beauty. The Greeks might have called it cosmos, meaning order, and they wouldn't have been wrong. You pass now through one of the vast voids, immense regions spanning hundreds of millions of light years with barely a galaxy in sight. The emptiness here feels physical, almost tangible. If silence had weight, it would be this. Even here, dark matter leaves a faint trace, thinner and more diffuse, the skeletal whisper of structure stretched to its limit. You think of it as the cosmic equivalent of still water, motionless, vast and meditative. And then, from the edge of that void, you see light again. Another filament rises into view, connecting to the one you left behind, forming a lattice so large it dwarfs imagination. Scientists once compared its scale to a map of neurons in the human brain, each galaxy a glowing cell, each filament a synapse of cosmic thought. The comparison isn't perfect, but it's unsettlingly apt. Both systems, brain and universe, seem to thrive on complexity built from simplicity. Perhaps consciousness is just the universe folding inward to admire itself. You can't help but grin at the absurdity. Here you are, a speck of awareness floating among galaxies, contemplating the very network that made your existence possible. You wonder if dark matter, in its silence, notices you noticing it. Probably not, but the thought itself feels like participation, a tiny ripple of curiosity moving along the gravitational web. Far below, a supercluster stretches across hundreds of millions of light years, a tangle of glowing threads. Astronomers call it Laniakea, the immense heaven. The Milky Way is one of its quiet suburbs, orbiting lazily through the dark. You realise that even your home galaxy is merely a note in this cosmic symphony, resonating within the web's grand geometry. The dark matter continues its eternal work, unseen, unmeasured, yet perfectly reliable. Every movement of light, every shape of galaxy, every tendril of structure is its art. And as you float there, suspended in its invisible threads, you feel something profound settle into you, a sense that the universe isn't chaotic after all. It's connected, coherent, and quietly held together by the dark fabric that underlies everything. You take one slow breath and exhale into the infinite. The stars shimmer faintly along the filaments, each one a candle in the cathedral of the cosmos. You can't see the walls, but you know they're there. The invisible lattice of dark matter holding it all in place, humming softly in frequencies older than light. You glide now along one of those filaments, curious about what lies beyond the glowing galaxies and the soft gravitational hum that fills the void. It's time to ask what this dark substance actually is not. You've heard its name whispered with awe and mystery, but the truth is that scientists have spent more time crossing off wrong answers than finding the right one. The universe, it seems, loves a good guessing game. You float beside a distant spiral galaxy, watching its luminous disk turn lazily, and you can't help but smirk. Even after decades of study, humanity still has a cosmic lost and found box, labelled dark matter, and it's embarrassingly empty. Back on Earth, the early theories about the missing mass were oddly charming in hindsight. Astronomers first suspected there might be ordinary stuff out there, just dimmer, colder, harder to spot. Maybe space was full of dead stars, burnt-out suns, rogue planets, or vast clouds of unseen gas. Collectively, they were called MACHOs, massive compact halo objects. And for a while, the idea felt solid. After all, what's more comforting than thinking the universe is missing ordinary matter instead of inventing an invisible one? So researchers built telescopes and watched patiently for microlensing events, brief twinkles in starlight caused when a compact object passes in front of a distant star. They found a few, but not nearly enough to explain the vast gravitational forces at play. The universe, with its usual dry humour, handed them crumbs instead of a cake. Historians still argue whether that early focus on machos slowed progress, or simply set the stage for more exotic ideas. Some say scientists were clinging to familiarity, others argue they had to eliminate the obvious first, the way you check under your bed before blaming ghosts. Either way, by the late 90s, it was clear. There weren't enough faint stars, planets, or gas clouds to explain the gravitational glue holding galaxies together. Dark matter had to be something else, something stranger. You pass through a faint haze of interstellar gas now, thin as breath and glowing softly in the starlight. It's beautiful, but irrelevant to the dark mystery. Even if the entire galaxy were filled with invisible hydrogen, it still wouldn't provide enough mass. Astronomers had measured it, weighed it, dismissed it. The math simply refused to play nice. Dark matter wasn't baryonic, meaning it wasn't made of protons and neutrons like the stuff you and your morning coffee are made of. It was something entirely different. The idea unsettled many scientists at first. The universe, they realised, might be built from two kinds of matter that barely acknowledge each other. Ordinary matter, the kind that forms planets, life, and light, is a rare minority. The rest is the unseen scaffolding, the deep foundation that never shines. You imagine dark matter and normal matter as two dancers sharing the same floor but never touching, moving to rhythms only gravity can hear. You drift toward a cluster of galaxies, each halo shimmering faintly with gravitational potential, and think about how this invisible component refuses every invitation to show itself. It doesn't emit light, doesn't absorb it, doesn't scatter it. It slips through stars, planets, and you without so much as a nod. The only reason we know it's there is because of how it tugs. The universe, you realise, is like a puppet show viewed through frosted glass. What we see is light, but the strings belong to something else entirely. Fringe theorists have proposed everything from swarms of black holes to ancient relic particles left over from the dawn of creation. One wild idea from the early 2000s suggested that dark matter might be composed of mirror matter, an entire shadow version of our universe where particles interact through their own mirror forces. In that reflection world, there might even be mirror galaxies and mirror stars, all invisible to us but gravitationally entwined with our own. It sounds like science fiction. And maybe it is, but the equations behave nicely when you let imagination have a seat at the table. Historians still debate whether physics thrives more on bold ideas or careful restraint. Some say theories like mirror matter keep science alive by daring it to dream. Others think they risk turning cosmology into mythology with better math. But for now, those ideas remain intriguing footnotes, beautiful, unproven whispers at the edge of understanding. As you drift through this galactic crowd, you find yourself amused by the irony that the universe's dominant ingredient is defined entirely by absence. Humanity can measure its gravitational footprint, yet still can't say what it's made of. Astronomers sometimes joke that dark matter is like the quiet person at a party, doesn't talk, doesn't eat, but somehow pays for the entire event. You chuckle softly, letting the stars around you twinkle in agreement. Below you, a faint galactic stream stretches between two galaxies, a ribbon of stars torn loose during a collision. You think about how dark matter shapes even these delicate scars. Without its halos, galaxies wouldn't dance and merge in such intricate choreography. The unseen determines the beautiful, always. You pause, letting the scale of it sink in. The search for dark matter has ruled out so much. No rogue planets in sufficient numbers, no dust clouds heavy enough, no faint stars abundant enough to explain the invisible mass. The more that scientists eliminate, the clearer it becomes. Whatever dark matter is, it's not ordinary. It's something beyond our familiar atomic reality, something that neither glows nor dies, something eternal in its quiet persistence. And maybe that's what makes it so hypnotic. The universe has left us with a mystery that resists every kind of instrument except imagination. You think of the hundreds of telescopes scanning the skies, the detectors buried in mountains, the supercomputers running endless simulations, and still, all we have is the evidence of the unseen. It's frustrating, yes, but also deeply human. We've always searched for meaning in the dark, from cave walls to constellations. Now we're doing it on a cosmic scale. As you drift onward through the halo of another distant cluster, the galaxies below you shimmer faintly, strung like beads across eternity. The light is fragile, but the dark is steadfast. The galaxies cling to it, shaped by it, unaware of their dependency. You close your eyes, letting the invisible gravity cradle you like a cosmic hammock, and you feel a strange calm. You don't need to see the unseen to trust it. Some mysteries are best left glowing softly in the background, keeping the universe together while we dream beneath it. You keep drifting through that invisible ocean, and the question finally surfaces: if dark matter isn't ordinary stuff, then what is it? You pass through the soft shimmer of a distant cluster, and somewhere in that motionless glide you sense a low hum, the faint echo of theoretical particles whispering from the frontier of physics. Scientists have given them names that sound like half-remembered fairy tales: WIMPs and axions, elusive candidates for the universe's missing mass. The acronyms sound almost playful, but the hunt behind them is anything but. It's the slowest, quietest chase in history, one that stretches from underground labs to the hearts of dying stars. WIMPs, weakly interacting massive particles, were the first suspects. They fit neatly into the mathematics of the early universe, appearing naturally in equations that extend the standard model of physics. They're heavy, they rarely interact, and they could have formed in just the right abundance after the Big Bang to explain the cosmic balance we see today. You picture them drifting through you right now, billions of them every second, silent ghosts that pass through the Earth without leaving a trace. A WIMP might pass through an entire planet as easily as light through glass, ignoring the atoms completely. That fact makes detection a nightmare, but it also makes the search addictive. Historians still argue whether the WIMP miracle, as it's sometimes called, was more inspiration or wishful thinking. Some physicists praise its elegance, the way it neatly explains both particle physics and cosmology. Others suspect the universe is mocking us for assuming nature prefers simplicity. Either way, the idea galvanized decades of experiments. Giant detectors were built deep underground, in mines, beneath mountains, even under polar ice, where cosmic rays and background radiation couldn't interfere. Tanks filled with liquid xenon or argon sit in eternal stillness, waiting for one of those invisible particles to bump into a nucleus and produce a tiny flash of light. It's a strange sort of optimism, waiting for a whisper in the dark, knowing you might never hear it. You float through that imagined stillness now, down into a subterranean cavern where scientists in clean suits move like monks in a cathedral of steel. The air smells of coolant and quiet purpose. They calibrate sensors, check data logs, sip coffee that's long since gone cold. Years pass and still the detectors remain silent. Occasionally they register a flicker, an ambiguous blip, but when examined it's always something mundane, a neutron, cosmic ray, a statistical hiccup. The dark remains uncooperative. Fringe theorists, of course, can't resist new ideas. If WIMPs won't show themselves, maybe the universe hides its secrets in something even smaller and stranger, axions. These hypothetical particles are light, almost massless, yet they could be produced in staggering numbers. If they exist, they'd behave more like waves than particles, filling the universe like a faint, invisible background hum. Scientists try to catch them using resonant cavities and magnetic fields, essentially enormous radio receivers tuned to the universe's quietest frequency. It's an elegant experiment, half physics and half patience. You imagine standing beside one of those detectors late at night, surrounded by the hum of machinery and the ache of possibility, wondering if the next signal will be the one that rewrites reality. Historians still debate whether axion research counts as bold exploration or cosmic gambling. Some compare it to listening for whispers in a hurricane, while others argue that every major discovery begins with a little madness. Either way, the labs keep listening. Somewhere beneath mountains in Italy, beneath the Black Hills of South Dakota, beneath the icy crust of Antarctica, detectors hum and wait. The scientists who tend them age quietly, passing on their faith like torchlight. You drift through the thought of them, humans devoting entire lifetimes to silence. There's something poetic in it. The search for dark matter is as much about patience as discovery. You can almost hear the ticking of their experiments echoing in time with your heartbeat. Maybe the universe enjoys the irony. Its greatest secrets pursued not by explosions or wars, but by stillness. Some researchers now think that dark matter could be even stranger than either WIMPs or axions. Perhaps it's made of sterile neutrinos, ghostly cousins of the known neutrinos that barely interact with anything. Or perhaps it's composed of something completely new, particles that don't even exist in our current physics. The frontier grows hazier the farther you look, and still, the evidence keeps pointing to something there. The gravitational pull of the unseen won't let go. As you float back toward the starlit plain, you glance across the billions of galaxies suspended in the cosmic web. Every rotation curve, every cluster, every distorted beam of light confirms the same truth. Something invisible holds it all together, and even though you can't see it, you can feel the strange satisfaction that comes with knowing the universe still has mysteries left. For all humanity's cleverness, quantum computers, gravitational wave observatories, telescopes that peer back in time, we're still children holding flashlights in an infinite forest. You imagine one day, perhaps far beyond your lifetime, someone finally catching a WIMP or detecting the hum of axions. Maybe they'll lift the veil, just slightly, and see what the dark is made of, but maybe not. Maybe the universe keeps its secrets for a reason, to remind us that wonder is part of survival. The stars around you flicker softly, agreeing in silence. You turn your gaze outward again, watching light stretch into faint ribbons as space expands. The dark matter doesn't glow, doesn't protest, doesn't explain itself. It simply exists, the most patient companion to all that burns. You realize as you drift that the invisible and the visible are not enemies but partners, the unseen shaping the scene, the quiet balancing the loud. It's a comforting symmetry, one that makes you exhale slowly and let your mind soften into stillness. Above you, a nebula curls in slow motion, its gas sculpted by gravity you cannot see. For a moment, it feels like you're watching the universe breathe. Somewhere, deep beneath mountains and ice, detectors wait for proof. Up here, among stars you already believe. You descend now, leaving behind the bright, humming filaments of the galaxies and heading downward, far below the mountains, below the crust of your little blue planet, into the quiet where Earth itself guards its secrets. Down here, beneath tons of stone and silence, humans are listening for the faintest tap from the universe's invisible side. You hover at the mouth of a long concrete tunnel that leads into an underground chamber the size of a cathedral, though instead of stained glass and hymns, there are cables, liquid nitrogen pipes, and tanks filled with noble gases chilled until they almost stop moving. This is where the search for dark matter grows monastic. The world above may be full of noise, but here, every sound has to earn its existence. You glide past the heavy blast doors of the Gran Sasso laboratory in Italy, where 3,000 feet of rock shield delicate detectors from cosmic radiation. Inside, scientists move like ghosts in white suits, adjusting instruments so sensitive they can detect a single photon, or a single lie told by the universe. They wait for dark matter particles, those theoretical wimps or actions, to collide with atomic nuclei and give off a flicker of light. Each flicker would mean a story, a revelation. But years pass and the lights stay dark. The detectors hum on, cold and patient, as though they too have learned the discipline of cosmic silence. Historians still argue whether such experiments represent science's highest faith or its most elaborate act of stubbornness. Some call these projects beautiful acts of optimism. Others see them as devotion bordering on obsession. Yet progress has always looked this way. Someone staring at nothing until it blinks back. It's how humans pulled meaning from constellations or coaxed radio waves from empty air. The dark, after all, has always been a place of discovery. You drift deeper still, through the mind's version of those caverns, and you can almost hear the whispers of other detectors around the world. The Lux Zeppelin experiment under the Black Hills, the Xeno NT detector in Italy, the Pandax in China, and the Ice Cube array buried in Antarctic ice. Each is a prayer to the unseen. These instruments don't shout their purpose, but they simply listen. It's the quietest science imaginable. A single atom trembling the wrong way could be the first conversation between ordinary matter and its shadow twin. Sometimes when researchers talk about their work, their voices waver between excitement and exhaustion. Imagine spending 10 years designing an instrument to detect a particle that might not even exist, then spending another 10 waiting for it to prove you right, or more often wrong. You can almost taste the devotion in the air, metallic and electric. The physicists joke, laugh, sigh, and recalibrate, then start again. They know that when the universe finally speaks, it will do so in a whisper. Fringe thinkers have proposed that maybe the detectors will never hear anything, because dark matter doesn't interact in any way we currently understand. Perhaps it passes through on different quantum channels. Or perhaps it's something emergent, an illusion born from gravity's geometry. It's the sort of speculation that makes theoretical physicists lean back in their chairs, rub their temples, and mutter either genius or nonsense. Yet even those wild ideas keep the field alive. The mystery demands imagination as much as mathematics. You float near one of the massive tanks, a gleaming cylinder of liquid xenon. It's colder than space itself, clear as glass. The sensors around it are tuned to detect a single faint photon, a spark smaller than dust. Every now and then, a cosmic ray sneaks through the shielding and sets off a false alarm. The scientists, rather than sighing, smile. They're grateful to know the instruments can still dream. They check the logs, recalibrate the systems, and return to their quiet vigil. There's a gentle rhythm to their work, like monks tending candles that rarely flicker but must never go out. Historians still debate how future generations will see these experiments. Will they be remembered as the first steps toward cosmic enlightenment, or as beautiful failures that pointed us in new directions? Either way, there's something deeply human about the pursuit. Even in the face of cosmic indifference, we keep asking the universe to tell us its secrets, certain that patience itself is a kind of success. You imagine the scientists leaving the lab late at night, stepping outside into crisp mountain air. Above them, the sky blazes with stars. Thousands of galaxies beyond sight, each one bound by the same dark matter they're chasing. They look up and know, with a mixture of humility and pride, that they live inside the very thing they seek. The irony would make them laugh if it weren't so quietly profound. You rise again, back through the rock, the crust, and into the open night sky. Earth spins beneath you, small and glittering, and you feel a strange tenderness for those patient minds hidden below. Their work is invisible, their triumphs rare, but their persistence mirrors the universe they study. Steady, silent, unyielding. The detectors keep listening, the stars keep moving, and somewhere between them lies the truth. It strikes you suddenly that the whole universe operates on this same principle: invisible effort sustaining visible beauty. The galaxies spin because of unseen matter. The scientists endure because of unseen hope. Both are kept in motion by forces they can't fully describe. You smile into the dark, understanding that maybe we don't need proof to keep believing. Sometimes belief itself is a kind of experiment. You drift away from the planet, watching its halo fade into the cosmic backdrop. The detectors below keep waiting. The sky above keeps glowing, and the space between them hums softly with promise. In that quiet tension, the universe feels alive, not because it speaks, but because it listens back. You drift upward and again, back into the black canvas where light itself becomes pliable. And the next clue to dark matter's existence reveals itself not through what it emits, but through what it bends. The stars here seem to ripple, like reflections on a lake stirred by invisible wind. You're watching one of the most exquisite illusions in the universe, gravitational lensing, the phenomenon where massive objects warp space-time so completely that light detours around them. Einstein predicted it in 1915, sketching the equations that turned gravity from a force into a geometric trick. But he could never have guessed how important this warping would become in mapping the unseen. From your vantage point, you hover near a cluster of galaxies glowing in faint coral light. Behind them lie galaxies even more distant, their photons travelling billions of years to reach you. Yet as that light passes through the cluster, its path curves, not because of the visible galaxy's mass alone, but because of something invisible, something far heavier, shaping the space-time between. What you see are arcs, thin, luminous crescents of background galaxies stretched and magnified, smeared across the sky like brushstrokes. It's not your eyes playing tricks, it's the universe itself bending its own reflection. Historians still argue whether this discovery, first captured in stunning clarity by the Hubble Space Telescope in the 1990s, was the moment dark matter truly became visible in its absence. Some call those distorted arcs the fingerprints of the unseen. Others prefer to think of them as the universe's confession, the cosmic equivalent of handwriting analysis proving the dark hand at work. Either way, gravitational lensing has become one of the most powerful tools for revealing where dark matter hides. You float closer to one of those shimmering arcs and can almost feel the gravity, gentle but absolute, curving the fabric of reality. It's an eerie sensation, like walking across a trampoline and realizing the ground itself moves under your step. The light bends obediently, tracing paths that shouldn't exist in a flat universe. And yet, this curvature is what lets astronomers map invisible mass. By measuring how the background light distorts, they reconstruct the shape of the unseen halo. The result looks like a ghostly fog surrounding each cluster, a gravitational shadow with no physical substance, yet enough weight to sculpt galaxies like clay. Fringe theorists sometimes joke that dark matter is the ultimate artist, using gravity as its brush and starlight as its paint. It's not a bad metaphor. You look across space and see entire murals made of warped galaxies, glowing arcs, and faint smudges, each a record of invisible presence. The bullet cluster, the cosmic web, the lensing arcs, they're all variations on the same masterpiece, different movements in a symphony of distortion. You imagine the scientists who spend their nights aligning telescopes to catch these delicate shapes. They process data for weeks, removing noise, stacking images, tracing arcs until the patterns emerge. Then, on a computer screen filled with pixels, the invisible begins to glow in colour-coded maps of density. Red for the densest dark matter regions, blue for thinner halos. The images are hauntingly beautiful, like thermal photographs of ghosts caught mid-motion. Historians still debate whether Einstein would have loved or loathed this use of his theory. He once described gravitational lensing as a curiosity, never expecting it to become a cornerstone of modern cosmology. But time, as always, has a sense of humour. His curiosity now allows scientists to see across billions of light years and measure the shape of things that refuse to shine. You wonder if he'd smile at the thought, light bent by darkness, revealing truth. As you drift through the cluster, the curvature of space itself becomes almost tangible. You realise that every photon you've ever seen, every glint of starlight, has travelled through this distorted web of gravity. Light is never straight. It's perpetually swayed by the unseen mass between stars, planets, and galaxies. The universe is one enormous lens, and dark matter is the glass that no one can polish. You pass into a quieter region now, where lensing is subtle, detectable only through statistics. Astronomers call it weak gravitational lensing, a cumulative effect visible only when you average thousands of galaxies together. It's the whisper version of the phenomenon, gentle, consistent, telling the same story at every scale. The result is unambiguous. Dark matter is everywhere, shaping not only clusters but the very texture of space-time. Fringe thinkers sometimes wonder if lensing could be the key not just to dark matter, but to new physics entirely. Perhaps the bending reveals hidden dimensions, or perhaps space-time is more flexible than Einstein imagined. It's speculative, yes, but speculation is the lifeblood of discovery. Every time light bends, the universe nods, whispering that our understanding is only halfway home. You pause over one of the grand lensing arcs, a background galaxy magnified into a perfect ring called an Einstein ring. The name feels fitting. The light has travelled for billions of years, wrapped neatly around an invisible mass, forming geometry out of chaos. You reach out in your imagination and trace its circle. It feels infinite, like a signature written by gravity itself. Below you, galaxies shimmer, each one a mirror of countless others across space and time. You realise how extraordinary it is that humanity, tiny and temporary, has managed to decode these patterns, how we've learnt to read light that was bent before our species even existed. There's a humility in that realisation, and an odd comfort too. The cosmos doesn't hide its secrets out of cruelty. It hides them, because that's the nature of beauty. To be glimpsed, not grasped. You close your eyes, floating amid invisible curves and delicate distortions. You picture the photons streaming past, carrying stories older than continents, guided by the quiet hand of the unseen. Somewhere, deep inside that silence, you sense a kind of serenity, the knowledge that the universe doesn't need to explain itself to be loved. Light and dark, curved and straight, visible and hidden, all part of the same exquisite balance. You open your eyes again. The arcs fade, the stars return to clarity, and the gravity that once bent your view now releases you, as if the cosmos itself has exhaled. For a fleeting moment you think you understand it. The invisible hand, the gentle warping, the truth that hides in distortion. Then it slips away again, like a dream upon waking. You drift now through a calmer region of the universe, your thoughts looping back to the mystery that began this journey. If dark matter is everywhere, could there be places where it's not? The question feels backward, almost rebellious. Yet as you glide past a quiet collection of galaxies glowing faintly in the deep dark, you find that a few of them seem oddly unanchored. They're spinning lazily, their stars barely bound, as though someone forgot to add the invisible glue. These are the outliers, the galaxies that appear to lack dark matter entirely. In a universe built upon hidden mass, their existence shouldn't be possible. And yet here they float, serene and puzzling. The first of these galactic oddballs made headlines in 2018 when astronomers studying NGC 1052 DF2 noticed something strange. Its stars moved so slowly that their combined gravity seemed enough to hold the system together. No dark matter required. For decades, astronomers had assumed the invisible halos were universal, the cosmic scaffolding beneath every galaxy, but DF2 refused to cooperate. Its motion said, "No thanks, I'm good." The discovery caused an uproar that rippled from observatories to conference halls. If dark matter was missing here, what did that mean for everything else we thought we knew? Historians still argue whether DF2 was a genuine revolution or a simple misinterpretation. Some scientists claimed the distance measurement was off, that if the galaxy was closer than estimated, its star's motions could still fit a dark matter model. Others insisted the data was solid and that the galaxy truly was a rebel. Follow-up observations only deepened the intrigue when another one, a DF4, showed the same independence. Two galaxies with nearly no dark matter. The universe had officially started trolling its own scientists. You glide closer to a hazy patch of starlight that might resemble one of these dark less wonders. It looks fragile, loosely assembled, more like a memory of a galaxy than the real thing. Without the heavy halo to anchor it, the stars drift in slow unison, their orbits wide and lazy. You can almost imagine them sighing in relief at their freedom, no invisible chains tugging them into tight formation. Yet you know that this freedom is temporary. Without dark matter's stabilizing gravity, galaxies like this can easily be torn apart by passing neighbors. Beauty, it seems, is fleeting when untethered. Astronomers theorize that such galaxies might have been stripped of their dark matter by tidal interactions, gravitational tides pulling the halos away during close encounters with larger galaxies. In that sense, these outliers aren't so much born without darkness as they are victims of cosmic theft. It's almost tragic when you think about it. Somewhere in the distant past, these galaxies collided or drifted too close to their brighter cousins, and in the exchange, they lost the invisible foundation that once held them together. You can almost hear the universe whisper, "Nothing survives untouched." Fringe theorists, never ones to miss an opportunity, have seized on these anomalies to argue that maybe dark matter doesn't exist at all. Perhaps gravity itself behaves differently in low-mass systems, an argument straight from the school of modified gravity models. They point to DF2 and DF4 as evidence that the laws of motion might bend subtly when there's less mass involved, a sort of cosmic quirk in the force. Mainstream astrophysicists politely disagree, but the debate keeps the midnight conversations lively at conferences. Historians still debate what these disagreements say about the scientific method itself. Some call them healthy proof that cosmology remains a living science. Others sigh that we've simply replaced theological arguments with equations. Either way, the universe has once again reminded us that simplicity is a myth. For every neat theory, there's always an exception twinkling at the edge of a telescope's field of view. You drift between two dwarf galaxies, their faint lights like dying embers. You can almost feel how delicate they are, how little gravity binds them. In some regions, the dark halos extend far beyond the visible stars. In others, like DF2, they seem to fade entirely. It's as though the universe mixed its ingredients unevenly, a cosmic chef distracted mid-recipe. The result is messy but strangely poetic, variety as proof of life. Down on Earth, astronomers refine their measurements, arguing over error bars and velocity dispersions while the galaxies themselves float on, oblivious to debate. Telescopes like Hubble and the newer James Webb Space Telescope capture clearer images each year, peeling back the haze to study how starlight scatters. With every improvement in technology, the story of these ghost galaxies becomes both sharper and more confusing. One observation will seem to confirm their lack of dark matter. The next hints that maybe the darkness is simply distributed differently. The mystery deepens, as all good ones do. You glance around the cosmic neighborhood and realize that galaxies come in endless flavors. Spiral, elliptical, lenticular, irregular, and each has its own relationship with the invisible. Some are heavy with dark matter, dense halos anchoring bright disks. Others, like these frail ones, are airy and adrift. The diversity is oddly reassuring. Even the universe resists standardization. A faint meteor streaks across your mental sky, just a bit of debris burning as it enters an atmosphere somewhere far away, and you think about how fragile light really is. The galaxies that lack dark matter might not last forever. In a few billion years, their stars will shatter, their identities dissolving into the intergalactic dark. Perhaps that's what makes them beautiful. Their defiance is temporary but brilliant. You hover there a moment longer, surrounded by starlight that shouldn't exist, thinking about how much of science begins with exceptions like these. The anomalies don't destroy our understanding, they refine it. Each one is a reminder that the cosmos is still writing itself, still full of corrections and surprises. The galaxies without darkness prove paradoxically that darkness itself remains indispensable. You drift onward, feeling the weightless hum of gravitational equilibrium return as you leave the region of outliers. The galaxies ahead shine more steadily, bound by their halos once more. The invisible hand resumes its grip, and the cosmic dance continues. Somewhere behind you, the rebels spin on, small bright protests against an otherwise obedient universe. You smile into the black and think, even in the cosmos, diversity is destiny. You continue drifting through the dark, watching galaxies turn like lanterns caught in slow tides, and a quiet question surfaces in your mind, the one whispered by skeptics ever since dark matter became a household term among physicists. What if it doesn't exist at all? What if the universe isn't hiding anything and it's our understanding of gravity that's incomplete? The thought is unsettling, but also thrilling. If true, it would mean that everything you've been feeling, the pull of unseen halos, the architecture of the cosmic web, the bullet clusters haunting separation, could be illusions created by a law that needs rewriting. Maybe it isn't the matter that's missing. Maybe it's our equations. The idea isn't new. In the early 80s, an astrophysicist named Mordechai Milgram proposed an alternative to the dark matter hypothesis, modified Newtonian dynamics, or MO. The name sounds like something you'd find on a forgotten chalkboard in Einstein's office, but it was revolutionary. Milgram suggested that at extremely low accelerations, like those felt by stars on the edges of galaxies, gravity behaves differently from Newton's law. Instead of weakening with the square of the distance, it flattens out, giving stars that mysterious extra speed without invoking any invisible mass. In his version, galaxies spin the way they do not because of hidden halos, but because gravity itself changes its tune in the cosmic outskirts. Historians still argue whether MOND was genius or folly. When it first appeared, many physicists dismissed it as mathematical duct tape, a patch job for a deeper ignorance. Yet against all odds, MOND's predictions worked remarkably well for individual galaxies. It explained their rotation curves neatly, elegantly, with fewer free parameters than the dark matter model. Some researchers whispered that maybe Milgram had stumbled onto something profound, something that even Einstein's equations hadn't captured. Others rolled their eyes and waited for the theory to crumble under more complex observations. Spoiler, it didn't entirely crumble, it just refused to win. You float now above a spiral galaxy, watching its outer stars zip along their orbits. MOND predicts these motions perfectly, but when you widen your view, when you look at clusters of galaxies or the cosmic microwave background, the model starts to wobble. Those large-scale phenomena still demand extra mass. So perhaps gravity isn't broken after all. Perhaps the universe is just multi-layered, mixing unseen matter with subtle gravitational quirks. The truth, as always, might be a cocktail of both ideas, served with a twist of mystery. Down on Earth, theoretical physicists sketch hybrid models that try to merge these perspectives: superfluid dark matter, emergent gravity, even entropic gravity. Each attempts to explain why the cosmos behaves as it does without relying solely on invisible particles. One idea suggests that gravity might not be a fundamental force at all, but a byproduct of entropy, a statistical illusion born from the way information distributes in space-time. It's equal parts physics and poetry, the notion that gravity is not a pull but a memory, a reflection of how matter rearranges itself through time. Fringe thinkers take it further still, proposing that maybe the universe we see is only a shadow of deeper geometry, higher dimensions curling in ways that mimic invisible mass. You picture reality like a crumpled bedsheet, its folds invisible from your limited angle, but their distortions altering the paths of light and motion. The hidden matter might not be matter at all, but curvature. The mind reels. You can almost hear Einstein chuckling from some corner of eternity, whispering, "Told you space-time was flexible." Historians still debate whether these modified gravity theories are genuine contenders or just elaborate distractions. Some praise their creativity, others call them a symptom of humanity's discomfort with ignorance. But you sense that even the arguments have their own beauty. Science, after all, thrives on dissent. Without the friction of disagreement, discovery would have no spark. Theories compete, collide and evolve, each one refining our picture of the cosmos, even when proven wrong. You glide past a distant galaxy cluster now, its shape slightly distorted by gravitational lensing. If MOND were right, this curvature shouldn't exist in quite the way it does, yet here it is, bending light with unmistakable precision. It's hard to argue with evidence that literally reshapes space-time. Still, something in you hesitates to dismiss the rebels entirely. After all, doubt is a healthy habit when staring into infinity. You imagine the community of cosmologists poring over their equations, each side convinced the other is missing something vital. The dark matter advocates have the weight of data. The modified gravity camp has the elegance of simplicity. You can see them both at conferences, smiling politely as they poke each other's theories full of holes, like cosmic tailors arguing over the shape of the same invisible garment. The debates can get heated, but beneath the rivalry lies mutual respect. Each camp, knowingly or not, helps the other sharpen its ideas. And so the universe keeps its secrets, smiling quietly behind the curtain. Perhaps the truth lies somewhere unexpected, something neither particle nor field, neither mass nor modification. The mystery endures not because we're wrong, but because reality is richer than any single story we tell about it. You float a little longer, pondering the symmetry of it all. Whether dark matter exists as tangible particles or gravity itself bends the rules, the effect is the same. Galaxies spin, clusters form, the cosmic web stretches across time. The universe doesn't care which equation explains it. It dances regardless. As you drift through that calm darkness, the distinction between unseen matter and unseen law begins to blur. You realize that maybe the point isn't to choose between them. Maybe the beauty lies in the search itself, in humanity's endless attempt to measure the immeasurable. You exhale softly, letting that thought settle like cosmic dust. The stars shimmer in the distance, indifferent yet inviting. Somewhere between the equations and the darkness, truth is waiting, patient, eternal, smiling faintly as you drift by. You drift farther from the galaxies now, rising into a quieter, colder space where the light grows thin and the scale of everything starts to lose meaning. Here, between the shining filaments and the emptiness of the cosmic voids, a different kind of darkness hums, one even more mysterious than the matter you've been tracing. This is the other half of the universe's invisible story, the one that doesn't just hold things together, but pushes them apart. You've reached the realm of dark energy, dark matter's distant cousin, and the quiet force behind the universe's accelerating expansion. If dark matter is gravity's sculptor, dark energy is its saboteur, pulling the fabric of space ever outward while galaxies cling desperately to their halos. You look back and imagine the Big Bang still echoing, a faint pressure radiating outward. For billions of years, gravity fought to slow that expansion, gathering matter into clusters, stars, and planets. Then, about 5 billion years ago, something shifted. Instead of slowing, the universe began to accelerate. Galaxies started drifting away from one another faster and faster, as if some invisible repulsion had awakened. The discovery came in the late 90s, when two rival teams of astronomers, each scanning distant supernovae to measure cosmic distances, found that the farthest explosions were dimmer than exceeded. The data didn't fit any known model. The cosmos, it turned out, wasn't coasting gently towards stillness, it was speeding up. The universe had found a way to step on the gas while no one was looking. Historians still argue whether that moment ranks among the greatest shocks in science or the quietest existential dread. Some say it was like discovering your house is expanding while you sit in it, slowly stretching the walls farther apart. Others compare it to learning that gravity, the most familiar force of all, can be overruled by something no one has ever seen or measured directly. To explain it, scientists invoked a new ingredient, dark energy, an invisible pressure woven into the fabric of space-time itself. In an instant, the universe's composition changed again. Roughly 68% dark energy, 27% dark matter, and just 5% everything else. Stars, planets, you. The math was humiliatingly poetic. We are built from the leftovers of mysteries. You drift through that expanding darkness now, feeling its subtle tug. It's not a wind or a push, but a quiet stretching, the slow elongation of space between galaxies. The galaxies themselves don't move, rather, the space between them grows. You watch a beam of light travel and feel the expansion pulling it, stretching its wavelength until it reddens, cools, fades. It's called cosmic redshift, and it's how astronomers measure the pulse of the universe's growth. Every photon you've ever seen carries that history, a faint record of the universe's stretching breath. Fringe theorists have suggested that dark energy might not be a thing at all, but a property of the vacuum itself, an intrinsic energy that space naturally possesses. Quantum mechanics predicts that even in absolute emptiness, virtual particles flicker in and out of existence, lending energy to the void. The trouble is that when you calculate how much energy that should be, you get a number that's off by about 20 orders of magnitude. It's the biggest mismatch between theory and observation in all of science. Somewhere the universe is laughing very quietly. Historians still debate how humanity will eventually reconcile this cosmic comedy. Some suggest that Einstein's cosmological constant, the term he once inserted then retracted in his equations, might have been right all along. Others believe dark energy evolves over time, a dynamic quintessence field that ebbs and flows like invisible weather. A few even argue that what we see as acceleration could be an illusion caused by geometry itself, a side effect of how we measure distant light. The truth for now remains suspended between elegance and chaos. You pass a cluster of galaxies and watch as their mutual gravity resists expansion. Within each cluster, dark matter keeps galaxies bound, refusing to let them drift apart. But beyond those clusters, the voids widen endlessly. You imagine the universe as a cosmic tug-of-war, dark matter pulling inward, dark energy stretching outward. For now, dark energy wins, and the expansion continues to accelerate. You can almost hear the slow sigh of space-time growing thinner. Somewhere far below on Earth, cosmologists map this acceleration using telescopes that chart how galaxies are distributed across billions of light years. They look for subtle patterns, ripples called baryon acoustic oscillations that trace the universe's ancient rhythm. Each measurement refines the cosmic recipe, though every refinement raises new contradictions. It's as if the universe lets us measure its pulse but hides the reason for its heartbeat. Fringe thinkers whisper even bolder possibilities. Maybe dark energy and dark matter aren't separate entities at all, but two faces of the same phenomenon, one attracting, the other repelling like cosmic yin and yang. Others go further, imagining a multiverse where each universe expands at its own pace, bubbles inflating within bubbles, dark energy determining which ones thrive and which collapse. It's impossible to test, but strangely comforting. Infinity, after all, has room for every theory. Historians still discuss how these discoveries have changed philosophy as much as physics. Once, humans imagined themselves at the centre of everything. Now we know we're not even made of the main ingredients. Yet instead of despair, there's a kind of liberation in that realization. The universe isn't smaller because it's mysterious. It's grander because we're invited to wonder about it. You drift a little farther, feeling the expansion subtly tug on your awareness. Galaxies recede like lanterns carried away by an unseen tide. Somewhere beyond your sight, the universe is already larger than light can travel to reach you. The horizon of the observable shrinks with every heartbeat, not because the universe ends, but because it runs ahead faster than you can chase it. There's a melancholy beauty in that truth, the knowledge that we can see only a fraction of all that exists, and even that fraction is fading. You let the thoughts settle like dust into the still air. Dark energy hums, softly, steady, inevitable. The stars keep burning, the galaxies keep spinning, and the universe keeps stretching, patient as breath. It isn't a race or a tragedy, it's a rhythm. The cosmos expands not out of loneliness, but because that's what it was born to do. You float in the widening silence, and for the first time you feel peace in the idea that even the universe, vast and ancient, is still learning how to grow. You drift backward in time now, slowly, gently, letting the universe rewind around you. Galaxies shrink to embers, clusters dissolve, and the great cosmic web folds in on itself until all that remains is a faint, uniform glow. This is the afterlight of creation, the cosmic microwave background, the oldest light you can ever hope to see. You're standing at the edge of the observable past, about 380,000 years after the Big Bang, when the universe finally cooled enough for light to travel freely. It stretches in every direction, not like a painting on a wall, but like the inside of a glowing sphere surrounding you. The light is ancient and tired, its wavelength stretched from visible brilliance to microwave murmur by billions of years of cosmic expansion, but it still holds the fingerprints of everything that followed. You let your gaze wander over the faint blotches and ripples in that all-sky glow. They look random, but they're not. Each tiny fluctuation, differences in temperature of only a few microkelvins, marks a region where matter was once slightly denser than its surroundings. Those invisible seeds grew under the steady pull of gravity into the galaxies and clusters that now decorate the universe. Dark matter, though unseen, was already there, gathering around those fluctuations like dew on spider silk. The luminous atoms merely followed its lead. Historians still argue whether the discovery of this relic radiation in 1965 was pure chance or destiny. Two radio engineers, Arno Penzias and Robert Wilson, were simply trying to calibrate a new antenna in New Jersey when they stumbled upon an annoying hiss that refused to disappear. They cleaned the equipment, chased pigeons from the horn, checked every circuit, and still the noise remained. Only later did they realize they were listening to the echo of the Big Bang itself. You imagine their baffled faces when theory and accident shook hands. Sometimes the universe rewards curiosity with static. The data grew sharper over the decades. First COBE, then WMAP, then the Planck satellite. Each mission refined the map of that ancient light, revealing not chaos but an astonishing order, subtle patterns that matched perfectly with models containing dark matter. Without it, the ripples in the early universe would have been too weak. Gravity alone from ordinary matter couldn't have pulled structure together quickly enough. Dark matter provided the extra weight needed for galaxies to form in time for us to exist. The map became both proof and prophecy. You drift closer, letting the microwave light wrap around you like warm fog. It hums in a frequency your ears can't hear, but your imagination fills in the sound, a low cosmic chord that has been ringing for 13.8 billion years. Every ripple in that soundscape encodes information: how much matter existed, how strong gravity was, how fast space expanded. Cosmologists read it the way historians read ancient scripts. The peaks and troughs in the data tell them that roughly 1/4 of the universe's mass energy must be non-luminous, our elusive dark matter again, making its quiet debut in the very first symphony of time. Fringe theorists sometimes claim the background light hides even more deeper messages. Some have hunted for imprints of collisions between universes, others for traces of primordial gravitational waves, tiny tremors that would confirm inflation, the brief burst of expansion that blew the newborn cosmos from subatomic size to astronomical scale. So far, the evidence teases but never commits, like a ghost waving from fog. Yet the search continues, detectors in Antarctica and space listening for ripples so faint they would make the bullet cluster look loud. Historians still debate whether inflation itself is a theory of genius or a convenient patch on the Big Bang story. It explains the smoothness of the universe, the distribution of matter, the alignment of cosmic structures, but it also opens questions about what came before. Was inflation triggered by a quantum fluctuation? Did it ever truly end? You can sense the uncertainty even in the calm voices of cosmologists giving lectures. They've learned to live with questions as vast as their data sets. You drift through the mottled sky of the early cosmos and realize that the CMB is more than evidence, it's memory. Every photon here has been traveling unbroken since atoms first formed, carrying a record of the universe's first sigh. Some of those photons are, at this very moment, entering the receivers of earthbound telescopes. Others brush past your imaginary self, continuing forever. You can't help but feel reverence. This light is older than stars, older than galaxies, older than the concept of dark matter itself. The radiation feels strangely intimate, like the background hum of existence that underlies every heartbeat. You remember that the same laws guiding these ripples guide the electrons in your own atoms. The patterns that shaped galaxies also shape the chemistry of your cells. The connection is literal. You are built from the cooled ash of that first explosion, structured by the same invisible forces you are now contemplating. A thought drifts through you. Maybe dark matter is the universe's first secret and dark energy its second. Between them lies everything luminous, the brief flicker of galaxies, of consciousness, of stories like this one. The early universe didn't know the difference. It only knew how to expand, cool, and remember. You watch the faint glow fade as time accelerates forward again. The temperature drops, the wavelengths stretch, the cosmos dims. Galaxies spark into being across the vastness you've just traversed. The universe awakens from its childhood, still whispering the same tune it began with. You smile, understanding that those whispers never stopped. They only became the background to everything we are. You exhale, feeling smaller and larger all at once, the echo of that ancient light vibrating softly through you. The past doesn't vanish here. It surrounds you, warm and infinite. You rise from that glowing cocoon of ancient light and find yourself gliding through a different kind of creation. Not the physical one that exploded into being, but the digital one that humanity now builds in its image. Around you, universes bloom not from atoms, but from algorithms. Supercomputers hum in quiet, air-conditioned rooms on Earth. Yet up here, you can see the results of their imagination stretching out like living constellations of code. These are the simulated universes, models so intricate that each pixel represents millions of solar systems. each calculation a billion years of cosmic history compressed into seconds. You drift between them as if between realities, watching as digital galaxies twist and spin, obeying the invisible rules of dark matter. In one of these virtual cosmoses, you see halos of simulated dark matter forming first, long before light arrives. The computer begins with almost nothing, a random distribution of particles, slightly uneven, and lets gravity do the rest. Slowly, those tiny ripples grow into filaments and nodes, the same cosmic web you've already explored, but now unfolding at breathtaking speed. It's like watching time-lapse footage of creation itself. Within minutes of computation, billions of years pass. Galaxies spark along the filaments, glowing with artificial brilliance, their shapes and motions eerily familiar. If you didn't know better, you'd swear you were looking through a telescope rather than at a screen. Historians still argue whether these simulations count as art or as science. Some call them the most honest form of storytelling we've ever achieved, equations sculpting a universe from scratch. Others worry that the elegance of simulation can seduce researchers into mistaking beauty for truth. After all, a model can match the real sky perfectly and still be wrong if it rests on a flawed assumption. Yet the progress is undeniable. Every major cosmological discovery of the last few decades has been accompanied or even anticipated by these computational experiments. You drift closer to one of the most famous simulations, the Illustris project. A digital universe crafted in the early 21st century. Within it, 12 billion particles of dark matter evolve under gravity's patient hand. The simulation begins just after the Big Bang and ends with the formation of galaxies that look uncannily real. Spirals, clusters, filaments, all behaving exactly as observation predicts. The dark matter halos provide the invisible structure, while the virtual gas clouds cool, ignite, and birth stars. Watching it unfold feels almost divine, yet humbling. The creators aren't gods, they're programmers translating physics into poetry. You pause to study one detail, how each digital galaxy sits inside its halo, like a pearl in a translucent shell. When astronomers compare these models to real sky surveys, the match is astonishing. The clustering of galaxies, the distribution of mass, even the subtle asymmetries all line up. It's one of those rare moments when the universe and the computer nod in agreement. Fringe theorists sometimes wonder if our own reality could be such a simulation, if the laws of physics are just code running on a cosmic processor somewhere beyond comprehension. You smile at the idea. It's both terrifying and hilarious, but there's something philosophical hiding beneath the absurdity. If we can simulate universes that behave like the real one, perhaps the act of creation, of modelling, isn't imitation at all, but understanding. We're not pretending to be gods, we're learning the language they would use. Historians still debate how these projects have transformed science culture itself. Once astronomers were wanderers and dreamers, now they're also programmers and data architects. The telescope has been joined by the server farm, the observatory by the simulation cluster. It's a new kind of exploration, one conducted not with rockets but with equations. Yet the spirit is the same, a yearning to see what lies beyond sight. You drift deeper into another digital universe, this one from the Millennium simulation. The screen fills with colour-coded threads, blue for dark matter, orange for gas, white for new stars. The patterns mimic the real cosmic web so closely that it's hard to tell which is which. You can almost feel the gravity in those lines, the invisible pull shaping everything from clusters to voids. It's mesmerizing, like watching the universe dream about itself. The computers that run these models are colossal. Millions of processors working in concert for weeks or months, their circuits glowing with purpose. You picture the scientists who built them, tired faces lit by monitor light, hands hovering over keyboards, eyes reflecting simulated galaxies. They're explorers too, though their ships are made of code. Each run begins with a question. What if dark matter interacts with itself? What if it's warm, not cold? What if its particles decay over time? The computers answer with entire universes. Fringe ideas even test self-interacting dark matter, where invisible particles collide gently, creating smoother halos that match real observations better. Others experiment with warm dark matter, slightly lighter particles that erase small-scale structures. The simulations are playgrounds for hypotheses, each one bending the cosmic rules just enough to test possibility. Watching them, you realise that discovery doesn't always happen in space. It often happens in the space between imagination and mathematics. Historians still marvel that the simulated universes of today are already helping to design the telescopes of tomorrow. By comparing digital predictions with what instruments like the Vera Rubin Observatory will soon observe, scientists can narrow their search, refine their expectations, and maybe, finally, catch the whisper of the real thing. You pull back from the simulated cosmos, watching dozens of universes spin and glow on invisible screens. It's strangely emotional, the realization that humans, tiny as we are, have built reflections of the universe that raised us. We've recreated the scaffolding of dark matter, not just to understand it, but to participate in its story. The computers hum like distant stars, and you feel a small warmth in the thought that curiosity itself might be the most powerful force in the cosmos. As you drift away from the virtual webs and back toward the real ones, you realize that the line between them has blurred. Both are born from gravity, data, and wonder. Both are proof that the invisible can be made visible if you're patient enough to listen. And so you float onward, knowing that somewhere a supercomputer is still dreaming the universe into motion, pixel by pixel, particle by particle, in a quiet symphony of simulated eternity. You move through the simulated darkness and emerge once again into the real cosmos, a place that feels no less surreal. The stars glimmer like scattered punctuation marks in an endless book, and you realize that everything you've learned so far only hints at how strange this universe might truly be. The physicists have neat acronyms, WIMPs, axions, but there's a growing menagerie of other possibilities that don't fit neatly into any category. The scientific journals sometimes call it the dark zoo, and as you glide through this next stretch of space, you can almost imagine the invisible creatures prowling through the vacuum. Black holes the size of atoms, ghostly neutrinos, particles that flicker in and out of existence like quantum fireflies. The universe, it turns out, might be a jungle we've barely entered. You pass near a region where stars cluster around a dense, invisible mass. It could be one of those ancient beasts, primordial black holes. They're not like the ones born from collapsing stars. These, if they exist, and would have formed in the chaos of the early universe, when matter and energy fluctuated wildly. Some may be as small as mountains, yet weigh as much as planets. Others could be microscopic, evaporating through Hawking radiation like drops of dew in sunlight. If enough of them survived, they could make up all or part of the dark matter we seek. It's a tantalizing idea, though still unproven. Astronomers scour the skies for their faint gravitational lensing signatures, hoping to catch one by the shadow it casts upon starlight. So far, the results remain inconclusive, but the possibility lingers. Cosmic fossils from the first seconds after time began. Historians still debate whether Stephen Hawking's prediction of evaporating black holes was a stroke of genius or a mathematical mirage. Some say those tiny black holes should have long since vanished, leaving only high-energy gamma rays as their death cry. Others think we might be missing the signals entirely, blinded by the static of our own galaxy. Either way, the theory has a poetic symmetry. The universe, born from energy, recycles its smallest monsters back into light. You drift farther and feel the faint flutter of neutrinos streaming through you, trillions per second, mostly harmless, mostly ignored. They barely interact with anything, yet they're everywhere, like the breath of the universe itself. Standard neutrinos are too light to explain dark matter, but some researchers suspect a heavier cousin exists, the sterile neutrino. It would pass through everything, even detectors, without leaving a trace, except through its gravity. If such particles fill the cosmos, they could account for the missing mass, drifting invisibly through galaxies like a slow, gravitational fog. Experiments on Earth and in orbit have hunted for them in the decays of known particles, but the evidence flickers in and out like starlight through clouds. Some data sets whisper yes, others shout no. The sterile neutrino remains a phantom among phantoms. Fringe theorists, of course, go further. They propose dark photons, cousins of light that interact only with dark matter itself. If true, that means dark matter particles might have their own forces, their own chemistry, even their own invisible ecosystems. You pause on that thought, half amused, half awed. Somewhere, entire galaxies could be glowing in dark light, structures that overlap with our universe but never touch it. You picture them as ghost constellations. They're stars invisible, but their gravity real. It's the ultimate parallel reality, a cosmos beside ours, perfectly intertwined yet forever separate. Historians still argue whether this line of thinking stretches science or imagination further. Some call it speculation dressed in equations, others see it as the next logical frontier. After all, the visible universe once seemed complete until the discovery of the unseen reshaped it. Maybe dark matter will do the same again, expand not just our understanding but our definition of real. You drift through a region of space where galaxies thin out and cosmic silence deepens. It feels like passing through the outskirts of thought itself. The gravitational pull here is faint, a whisper rather than a song, yet it still reveals the shape of something larger. You can almost sense the invisible menagerie around you, each idea shimmering faintly in probability space. Primordial black holes roaring silently, sterile neutrinos drifting like fog, axions humming softly through magnetic fields, dark photons zipping through the vacuum unseen. The universe hums with possibilities, each one waiting for proof. Far below, in laboratories lit by the sterile glow of monitors, scientists run simulations of these exotic creatures. Some models show primordial black holes accounting for a fraction of dark matter. Others dismiss the idea entirely. The sterile neutrino crowd recalibrates their detectors. The Axion teams tune their resonant cavities a little finer, straining to hear the quietest song in the cosmos. It's a zoo without cages, where every hypothesis roams free until observation tames it or extinction erases it. Fringe communities online sometimes latch onto these ideas and turn them into cosmic folklore. You've probably seen the headlines, "Dark matter is made of invisible black holes," or "The universe is full of ghost galaxies." They're not entirely wrong, just impatient. Science moves slowly, politely, always double-checking before declaring what's true. The universe, patient as ever, seems content to let us stumble toward understanding. You float through this invisible jungle, feeling a kind of affection for all the theories, even the wild ones. Each one is an act of imagination, a reminder that curiosity is a form of courage. To face the vast unknown and say, maybe it's this, even knowing you might be wrong, is one of humanity's bravest habits. The scientists working late into the night chasing sterile neutrinos or phantom black holes are not just hunting particles, they're expanding the boundaries of wonder. As you drift on, you realize that the dark zoo isn't just a collection of hypothetical creatures, it's a metaphor for the way science works. Every mystery begins as a rumor, every rumor as a theory, every theory as an invitation to look closer. The universe doesn't hand out answers, it hands out clues disguised as contradictions, and we, persistent as gravity, keep following them. You glance one last time into the deep dark around you. Maybe there are black holes smaller than dust, or particles that shimmer only in dimensions we can't yet see. Maybe the truth will be something so strange it makes us laugh at our own seriousness. Whatever it is, it's out there, waiting. Quiet, patient, invisible, yet as real as the light that guides you through the night. You drift onward, leaving the hypothetical zoo behind, and find yourself back among the humans, the fragile, brilliant species determined to understand what even the universe seems content to keep secret. You hover above a small research facility tucked into the mountains of Chile, where dawn paints the Atacama sky gold. Inside, a handful of scientists stir their coffee, review night-long observations, and prepare for another day of patient hope. The hunt for dark matter has always been both epic and intimate. An entire cosmos hidden in data sets, entire lifetimes spent chasing a single flicker that might never come. You imagine what it feels like to dedicate decades to something invisible, to wake up knowing you may never see results, that your contribution might only be a stepping stone for someone else centuries from now. Yet these people keep working, drawn forward by the same quiet gravity that binds galaxies. Their lives, though ordinary on the surface, school runs, grocery lists, unanswered emails, are threaded through with cosmic purpose. They build the detectors, analyze the noise, and stare at graphs until their eyes ache, searching for the whisper of the unknown. Historians still argue what drives them most: curiosity, ego, or devotion. Some call it scientific faith, an almost religious persistence in a universe that rarely rewards certainty. Others see it as humanity's oldest instinct to light a torch in the dark, no matter how vast that dark might be. You suspect it's both. To search for dark matter is to participate in an act of cosmic intimacy, to press one's ear to the universe and listen for its heartbeat. In your drifting vision, you watch a graduate student deep underground in South Dakota, sitting beside the liquid xenon detector she's helped calibrate. It's late, the lab hums quietly. She eats a granola bar and scrolls through readings that all say the same thing. Nothing. No particle collisions, no unexpected flashes, just silence. And yet she smiles faintly. Even silence is data. It means the system is working. It means the mystery continues. There's a strange peace in that. Half a world away, a team in Japan refined software to remove background noise from satellite observations. A single line of code might one day help distinguish the gravitational tug of dark matter from the random motion of cosmic dust. It's tedious work, the kind that never makes headlines, but without it, the grand theories would crumble. Science, you realize, is a mosaic built from countless invisible pieces, each contribution anonymous yet essential. Fringe theorists often paint scientists as heroes or villains, but the truth is quieter. They're human, funny, flawed, or bleed, caffeinated. They argue over funding, steal each other's pens, and occasionally fall asleep in lecture halls. But when the data come in, even rivals hold their breath together. Discovery, when it happens, belongs to everyone. You glide through the thin air above CERN, the particle collider nestled beneath the French-Swiss border. From up here, it looks almost peaceful. But below the surface, protons scream around a 17-mile ring at near light speed. The scientists here have chased dark matter from the opposite direction, not through telescopes, but through collisions so violent they briefly recreate the conditions of the early universe. They've searched for supersymmetric particles, potential WIMPs hiding among debris fields of shattered atoms. So far, nothing. Yet every nothing adds another constraint, another corner turned in the labyrinth. Historians still debate whether humanity's obsession with the invisible is a strength or a flaw. Some say it reflects hubris, our refusal to accept that not everything is knowable. Others see it as courage, the belief that truth, however distant, is worth the journey. You suspect it's both again. There's humility in staring at the stars and knowing you'll never finish the story. Only write your line in the margins. You drift lower, through the quiet hallways of universities, where whiteboards are covered in equations that look like alien languages. In one office, a professor tries to explain to her students how gravitational lensing can reveal the mass of the unseen. The students nod, some out of comprehension, others out of politeness. She pauses and smiles. "Don't worry if it doesn't click yet," she says. "The universe isn't in a hurry." You almost laugh. That might be the most accurate thing anyone's ever said about cosmology. Fringe communities online sometimes mock these pursuits, calling them expensive exercises in futility. But even that skepticism is part of the dialogue. Every great scientific leap was once accused of being a waste of time. Heliocentrism, relativity, quantum mechanics. You think of Galileo peering through his telescope and seeing moons around Jupiter. He didn't know he was changing history. He was just checking if the math matched the sky. The scientists chasing dark matter are doing the same thing, just on a much grander, lonelier scale. You imagine one of them, older now, grey-haired, his research unfunded for years, still attending conferences, still presenting graphs that most people skim past. He laughs when asked if he'll ever retire. "You don't retire from curiosity," he says. "You just slow the orbit a little." You can almost see the starlight in his tired eyes. Historians will one day tell the story of this era, of underground labs, of silent detectors, of dreamers who believed that reality extends beyond sight. They'll call it the Age of Shadows, perhaps, or the Great Listening. What they won't capture is the emotional gravity, the nights when scientists stared at their screens and wondered if the universe was laughing at them or if it was waiting, patient for them to listen harder. You float there, weightless and moved, realizing that the human search for dark matter isn't about physics alone. It's a mirror of our oldest longing, to understand what holds us together when nothing visible seems enough. The cosmos may be made mostly of unseen mass, but so are we, held together by faith, curiosity, and the gravity of wonder. You close your eyes for a moment, letting that parallel settle inside you. The universe expands, humanity keeps asking. Both motions feel the same. You drift farther from the laboratories, from the whir of cooling systems and the clatter of keyboards, and you find yourself back in the quiet dark where thought itself seems to echo. It's time to step back from data and instruments and face the deeper question hiding underneath. What does it mean that most of the universe is invisible? The philosophical weight of dark matter presses against you here, heavier than any gravity well. If existence is mostly unseen, then how real is real? You look at the galaxies wheeling in slow silence, each one lit by the faintest dusting of stars, and you realize that everything luminous, everything we call visible, rides atop an ocean of shadow we can't touch. It's a humbling perspective, one that reshapes not only science but the human sense of self. For centuries, humans believed that seeing was knowing. I'll believe it when I see it, we used to say, as if vision were the highest authority. But dark matter laughs softly at that. It reminds us that truth doesn't always reveal itself to the eye. Even now, you're surrounded by more gravity than light, and yet you call this space. Perhaps what we call emptiness is simply what we fail to comprehend. You drift slowly through that thought, watching faint galaxies slide past like slow-motion fireworks, and you wonder if consciousness itself has limits as fundamental as the speed of light. Maybe there are entire aspects of reality, forces, dimensions, even forms of awareness that lie forever beyond our sensory range. Historians still argue whether the discovery of the unseen universe has changed humanity's worldview as profoundly as Copernicus once did. Some say yes, just as we were dethroned from the centre of the cosmos, now we're demoted from even being made of the same kind of matter as most of existence. Others claim it's not demotion, but expansion, that to realise we are part of a larger, invisible architecture is a kind of elevation. You can almost hear their voices debating in lecture halls centuries from now, students scribbling notes beside diagrams of dark halos, and quotes from philosophers who tried to make sense of them. Fringe thinkers, of course, go further still. Some see dark matter as metaphor, the cosmic equivalent of the unconscious mind. They suggest that just as our waking thoughts depend on unseen mental structures, so too does visible matter depend on hidden mass. It's a seductive parallel, the psyche and the cosmos, both stitched together by things we can't directly perceive. Others whisper that perhaps the universe is conscious, that the vast web of dark matter might form a kind of cosmic nervous system, transmitting gravitational signals faster than light could ever travel. There's no evidence of it, of course, but then again, imagination is its own kind of experiment. You think of ancient myths, how people once described unseen forces as spirits or gods. They named winds, rivers, and stars after deities because they sensed the universe was alive with unseen will. Maybe dark matter is our scientific version of that same instinct, the urge to name the invisible, to wrap mystery in meaning. The difference is that now we use equations instead of prayers, though both you realise are languages of awe. Historians still debate whether physics and philosophy can ever truly reconcile. One deals in measurement, the other in meaning. Yet when it comes to dark matter, they overlap like twin shadows. The scientist asks what it is. The philosopher asks why it hides. The artist might ask how it feels. And you, floating here in the quiet void, realise that all three questions point to the same yearning, to find coherence in a universe that withholds it. You watch a distant spiral galaxy spin, its arms wrapped in luminous gauze. You can see the stars, the dust lanes, the glowing centre, but the real weight lies beyond sight, in a halo that extends far beyond the glow. It's a beautiful metaphor for life itself. Every action, every word, every heartbeat is surrounded by unseen causes and consequences. Just because we can't see the scaffolding doesn't mean it isn't holding us up. Fringe spiritualists sometimes claim that dark matter is the realm of souls, the invisible field where consciousness returns after death. Physicists politely roll their eyes, but the metaphor endures because it touches the same nerve that science cannot quite reach, the need to believe that invisibility doesn't equal absence. You can't disprove beauty just because it doesn't weigh anything. Historians still ponder how this new cosmology might change our definition of reality itself. When you tell people that 95% of existence is unseen, you're not just giving them a number, you're challenging their faith in perception. Philosophy becomes physics by another name. If we are part of a universe where invisibility dominates, then maybe mystery isn't an obstacle to knowledge but a fundamental property of it. The universe isn't withholding truth, it is truth, disguised as curiosity. You let that thought settle, warm and steady. Perhaps dark matter isn't a riddle to be solved, but a reminder to stay humble. Maybe the cosmos needs its secrets to remain alive, just as you need unanswered questions to keep moving forward. You look out into the dark and realize it's not empty. It's full of potential, of everything waiting to be discovered, imagined, or simply accepted as unknowable. The stars flicker softly, and their faint light glows against the unseen mass surrounding them. You feel the equilibrium between the visible and invisible, the known and unknown, the conscious and the hidden. You think of the scientists still searching, the philosophers still writing, the dreamers still wondering, and you realize you're part of their gravity too. You are one more mind orbiting mystery, pulled toward it not by need, but by love. You exhale, and the sound disappears into the vast, invisible fabric that holds you. The silence feels sacred. Maybe that's the point. Maybe the universe's greatest gift isn't the answer, but the endless invitation to keep asking. You begin to drift again, farther from reflection and back toward motion, back toward the future tense of the universe, the part of the story still being written. Ahead of you, the darkness stirs with potential. It's not emptiness anymore, it's anticipation. The hunt for dark matter is far from over, and even as you float through the silence, you can sense the instruments of discovery awakening across the cosmos. The next generation of explorers isn't watching the sky with their eyes, but with technologies fine-tuned to the faintest tremors of the invisible. You can almost hear them humming below. Telescopes, sensors, quantum arrays, and each one a new ear pressed to the heart of creation. From your vantage point, the Earth glows faintly beneath its sheath of clouds. You can see the Vera Rubin Observatory in Chile, still unfinished but already legendary, its mirrors polished to absurd precision. When it begins its legacy survey of space and time, it will photograph the entire southern sky again and again, catching changes so subtle they might reveal the gravitational fingerprints of dark matter, clumps no one has ever mapped before. Each night will yield terabytes of starlight, millions of galaxies catalogued, compared and modelled. Somewhere in that deluge of data may lie a pattern, a hint of how the invisible holds the visible together. Historians still argue whether the modern era of astronomy marks the end of curiosity or its rebirth. Some worry that automation turns wonder into numbers, others say it frees the human mind to dream bigger. The truth, as usual, is in the tension between them. Even as machines gather data, it's still people who look at the graphs and gasp quietly when something unexpected appears. A glitch, a ripple, a faint distortion. Each could be the moment the universe winks back. You glide eastward toward China, where the giant underground Pandax detector listens beneath kilometers of rock. Its sensors are so sensitive that a single rogue cosmic ray can ruin hours of data. Farther north, new detectors built from supercooled crystals are being prepared in Japan and Korea. Their goal? To feel the gentlest nudge of a passing dark matter particle, something lighter and rarer than any WIMP yet imagined. You picture the scientists descending in elevators deep into the mountain, their helmets' lights reflecting off stone walls like fireflies. They don't speak much on the way down. What is there to say when you're about to enter a chamber where the universe might whisper? Fringe engineers are even experimenting with quantum sensors, tiny devices capable of detecting gravitational fluctuations smaller than the width of an atom. Others are using pulsars, those cosmic metronomes, to track the faint tugs of dark matter as it flows through the Milky Way. The methods sound like science fiction, but the math is real, and the technology grows more precise with each year. You can almost feel the excitement rippling through the scientific community, a shared pulse that stretches from Antarctica's neutrino detectors to satellites orbiting the moon. Historians still debate what will happen if someone actually detects dark matter directly. Will it be a quiet press release or the modern equivalent of discovering fire? Some predict an explosion of new physics, whole branches of theory blossoming overnight. Others expect anticlimax, a confirmation of what most already accept. But beneath the speculation lies something tenderly human. The hope that discovery will remind us we are still explorers, that mystery still has edges we haven't touched. You drift through the memory of a future conference. Hundreds of scientists gathered in a glass-walled hall watching as data scrolls across a screen. There's a murmur, then silence, then applause that sounds almost reverent. Someone has found a pattern in the background noise, small but undeniable. Maybe it's the signature of a new particle. Maybe it's the first clear proof of self-interacting dark matter. You can't hear the words, but you feel the weight of the moment. History doesn't always announce itself with trumpets. Sometimes it arrives as a quiet sigh of relief. Meanwhile, space agencies prepare missions to map the cosmos in finer detail than ever before. The European Euclid Telescope, the Nancy Grace Roman Space Telescope, and Japan's Light Bird probe are all designed to trace the geometry of dark matter and dark energy across billions of light years. Together, they'll produce a 3D map of the invisible universe, a structure charting where gravity has been strongest and where the void still stretches. You imagine the final result, a shimmering hologram of everything unseen, the first portrait of the universe's true skeleton. Fringe futurists already dream of using dark matter itself as a tool, harnessing its gravity to detect distant planets, or perhaps to stabilize interstellar travel. It sounds fanciful, and maybe it is, but so did radio waves once. Every impossible idea waits for technology to make it obvious. You wonder what kind of civilization might one day look back at us and smile, the way we smile at alchemists for chasing the wrong metals but the right dream. Historians still wonder whether that future civilization will even be human. Maybe artificial intelligence will inherit this curiosity, continuing the search long after we're gone, scanning the heavens for the invisible mass that birthed us. The thought isn't sad, it's strangely comforting. Curiosity, like gravity, doesn't die, just transfers. You rise higher, looking down at the faint shimmer of radio telescopes and satellite dishes. From above, they resemble flowers blooming toward the void, petals of metal drinking invisible light. The Earth spins slowly beneath, patient and small, while the universe stretches outward, infinite and patient in return. For the first time, you realize that humanity's pursuit of dark matter isn't just about discovery, it's about belonging. We build detectors not because the universe demands it, but because we need to feel connected to something larger than ourselves. You let that understanding settle over you like starlight. The search will continue, through generations, through failures, through flashes of insight so brief they barely register before becoming history. Dark matter may never show its face, but the act of looking already defines us. The next century will be filled with deeper telescopes, colder detectors, braver dreams. And maybe someday someone will look up from their data and whisper, "There you are." Until then, the hunt continues, quietly, endlessly, beautifully, just as the universe intended. You float higher still until the Earth fades to a pale blue memory, and even the galaxies begin to blur together. The noise of human ambition, the hum of laboratories, the whispered arguments of scientists, all dissolve into the slow breathing of the cosmos. This is the end of the visible universe, the boundary where even imagination has to squint. Beyond here, the night grows softer, older, more absolute. And yet it isn't empty. It's full of potential. The same silent potential that existed before the first star burned, before the first atom coalesced, before gravity and time learned each other's names. It's here, in the deep quiet, that dark matter's story becomes something larger than physics. A story about presence without proof, about the comfort of mystery. You look out and see galaxies shimmering like fireflies caught in amber, each one a relic of billions of years. The farther you peer, the younger the universe becomes, until it fades into a faint mist of microwave afterglow. Somewhere beyond that haze is the unobservable, a realm expanding faster than light can chase. If you could cross that horizon, you'd find more of the same. Filaments, halos, voids, perhaps endless repetitions of the structures we know. The cosmic web doesn't end, it just retreats beyond reach. You realize with a slow exhale that the universe isn't a place at all. It's a process, unfolding forever in both directions, light and dark dancing in perfect tension. Historians still argue whether the concept of the edge of the universe makes any sense. Some say there is no edge, only a curvature so vast that light will never complete its circle. Others propose the multiverse, that our cosmos is just one bubble in a frothing sea of others, each with its own laws, its own kinds of dark matter, its own stories that will never meet ours. The mind resists such infinity, but you find the idea soothing. If the universe is endless, then so is possibility. Even if humanity never finds the invisible mass we seek, somewhere in another bubble, another species might have already understood it. Knowledge like gravity doesn't belong to any one world. You drift through the darkness, thinking about everything you've seen, or rather, everything you've failed to see. the galaxies spinning too fast, the invisible halos shaping the web, the quiet patience of detectors waiting for whispers. You remember the bullet cluster, the gravitational lenses, the scientists and philosophers, the simulated universes. Each was a clue, a chapter, a heartbeat in the same story. You begin to understand that maybe the search itself is the point. Dark matter holds galaxies together. Curiosity holds us together. The cosmos and consciousness both thrive on what remains just out of reach. Fringe thinkers sometimes suggest that the universe is self-aware, that every conscious being is the cosmos observing itself, evolving through wonder. You don't have to believe that to feel its beauty. The act of looking outward has always reflected inward. When you peer into the dark, you find yourself staring into your own depths, the unmeasured mass of memory, emotion, and imagination that makes you whole. Perhaps we each carry our own version of dark matter inside us, invisible influences, hidden gravities, the quiet forces that shape our lives. Love, loss, curiosity, they're the unseen scaffolding that keeps our light from flying apart. Historians still debate what future generations will make of this era. Maybe they'll laugh at our primitive detectors, our clumsy theories, our poetic awe, or maybe they'll envy us for standing at the edge of ignorance with such earnest courage. After all, discovery is sweetest when the darkness still stretches ahead. Once you map every shadow, the story ends. Maybe the universe hides its secrets not to frustrate us, but to keep the adventure alive. You look back toward the Milky Way, your home galaxy, glowing faintly against the endless backdrop. Its spiral arms wrapped around a halo of invisible matter, a reminder that even our home floats inside something greater. You think of Earth again, that fragile dot where people wake, work, to live and dream beneath skies they barely comprehend. The connection feels intimate now, almost sacred. The same force that holds galaxies together holds the rhythm of human hope. The same gravity that binds stars binds hearts. The same mystery that keeps the cosmos expanding keeps the imagination restless. You drift farther until even the Milky Way fades into the collective shimmer of all galaxies combined, a single pale thread in an infinite tapestry. The darkness around you is thick but not lonely. It feels like the pause at the end of a song, the stillness before another verse begins. Perhaps that's what the universe is, not a static masterpiece, but an eternal composition, its notes written in mass and light and time. You smile, realizing that somewhere, unseen, dark matter provides the rhythm, steady, patient, ancient as existence itself. You close your eyes one last time, letting the hum of the cosmos wash over you. You think of every discovery yet to come, every scientist not yet born, every night sky still waiting to be looked at with wonder. The search will continue long after you're gone, and maybe that's the most beautiful truth of all. We don't need to solve the mystery to belong to it. We already do, so you breathe in the silence and let it fill you, weightless and eternal. The stars drift away like thoughts returning to sleep. Somewhere behind them, dark matter holds everything steady. The galaxies, the light, the dreams, the small spinning world you call home. And in that infinite hush, the universe whispers, not an answer, but an invitation.